Okay, we're first going to review how to evaluate functions. So this is pretty simple. If this is our function f of x, we're trying to find f of 0. All you're going to do is plug 0 in where you see an x. So 0 squared plus 3 times 0 plus 5, which will give us 5. Okay. What this means is that 0, 5 is on the function f. Same thing with something like f of 3. You're going to simply plug in 3 where you see an x. So we're going to have 9 plus 9 plus 5, so that's 23. Okay. Alright, let's get a little more complicated. For us to evaluate, again, that word evaluate means find the value of. So if we're trying to find f of, in this case, x plus 1, we're going to plug in x plus 1 where we see x in our function up above. So all I'm doing here is where I see an x, I'm just plugging in x plus 1. So now I'm going to simplify. X plus 1 squared, be careful, you don't just square the two parts. We have to do FOIL. Okay. And then we distribute over here and combine our like terms. We have a positive 2x. We have a positive 3x. So that's positive 5x. And then we have our like terms here, of course. That's plus 9. And we're done. So this would be the value. Okay. Next up here, we have another expression. Again, very similar. F of x plus h this time. So we plug that in where we see an x into our function. Now we just have more than one variable. We have two variables, but it's still the same idea. Don't let the fact that there is another letter, h, in the problem bother you. So when we do our FOIL here, we're going to have x squared. Now off to the side, if you need to, write x plus h a couple times. All right. The inner and the outer will give us 2 hx's. If you write 2xh, that's the same thing, that's fine, plus an h squared. So that's from doing FOIL on the first part. Let's distribute. Alright, right there, just distributed, plus 5. Now if we scan across this and look for like terms, there aren't any. So this is as simple as we could make it. Okay? So there's no like terms, nothing to combine. Notice the first three examples say to evaluate. Now we have a question that says to solve. Now, if we're going to solve something, it has to be an equation. Notice that there's an equal sign. We're not looking to evaluate. Okay? A common mistake that people will make is they will treat this as f of 3. Okay, this is not equal to f of 3. This says to solve f of x equals 3. So we have to go back to what f of x was. Okay, so here's an equation that says f of x equals 3. So f of x from up above is x squared plus 3x plus 5. I'm going to bring down my equal sign and I'm going to bring down that 3. Okay, so I'm setting up an equation here where f of x is equal to 3. It says to solve, so that means we're trying to find x. So I'm going to subtract over my 3, make this quadratic equal to 0. So if I do that, I'm going to get a 2 over there. Don't forget to write equals 0. Well, from there we can factor and we can solve. So we're going to get x equals -2, x equals -1, And anytime we're solving for x, it makes sense to put our answers in a solution set. Okay? Alright, let's go on to our next page. We're now looking at finding the intercepts of a function. So, where a function touches the axes is called its intercepts. And there are two kinds. We have an x and a y intercept. So if we're talking about an x-intercept, alright, here's our x-axis, of course, here's our y-axis. If we're trying to find x-intercepts, since x-intercepts are where it's touching the x-axis, this occurs when y is 0. So to algebraically find x-intercepts, you're going to set y equal to 0 and solve for x. And likewise, if we are trying to find y-intercepts, we are looking for points where the curve is touching the y-axis. So these are some examples of where you would have a y-intercept. Well, this occurs when x is equal to 0. So to find it, you're going to set x equal to 0 and you're going to solve for y. Alright, now in terms of the possible number of x-intercepts, it's possible to have no x-intercepts. You could have 1, 2, and onward. Okay, it's possible to have something that looks like this. That's a situation where you don't have any. It's possible to have a situation where the function comes up and just hits it one time. Okay, let's pretend it's hitting it right there. Okay, you can of course have something that's coming along and hitting it several times. Okay, now y-intercepts. It's possible to have 0 y-intercepts and 1 y-intercept. If you're wondering how it's possible to have 0, you can have an absolute value function, something that perhaps looks like that. Notice it has no y-intercepts. You can certainly have 1 y-intercept. Here's an example of that up here. It's impossible to have more than 1 and for it to also be a function. If it had more than 1 y-intercept, it would fail the vertical line test. So those are your possibilities. Now let's look at some examples where we algebraically find our intercepts. So in our first one here, we have f of x equals, we have a quadratic here. So I'm going to organize my work. I'm going to write x and y like this and just kind of keep them separate. So to find my x-intercepts, we said you're going to set y equal to 0 and solve. Well, keep in mind that f of x is really the same as y. So we're going to set this function equal to 0, and you're just going to solve. This one turns out it's factorable. That's going to be x plus 5, x minus 2. Okay, and when we go to solve, x is going to equal negative 5, and x is going to equal positive 2. Alright, and let's get in the habit of writing our answers as coordinates. If we do that, since it's an x-intercept, we know y is 0, so we would have our points right here, our x-intercepts. For the y-intercept, we said this is where you're going to throw a 0 in for x. So 0 squared. So I'm just substituting in. When I do that, this cleans up nicely to just negative 10. So in this situation, since it's a y-intercept, x is 0. So I'm going to put the 0 first in the x position. Okay? We have 2 more examples. Now we have a square root function. So again, just to organize our work, I like to do something like that. So let's find our x-intercept first. Remember, this is where we said you're going to make y 0. So, oops, let me erase that. So we have x minus 8. Now in this case, if we're looking to solve for x after making y 0, since I have a square root function, I can square each side to get rid of that square root. So I'm going to end up with 0 equals x minus 8. That would give me x equals 8. So I know that this particular function will cross through the point 8, 0. Okay. Now the y-intercept, same idea. We're going to substitute in 0, but this time, since it's a y, we're going to plug in 0 where we see an x. So now we go to clean this up. We have the square root of negative 8. Hopefully you're thinking that doesn't really make sense. How do I take the square root of negative 8? Well, we can't. We get an imaginary number. So what this suggests, since we don't have an answer here, it doesn't mean you did something wrong. It means you don't have an answer. You don't have a y-intercept. So we have no y-intercepts. Remember we said earlier, one possible example is to have 0 y-intercepts. We have either 0 or 1. That's one possibility. Okay, our last one here. We have a rational function, which is just a function over a function. So I'm going to first define my x-intercept. Let me just do this. I'm going to throw 0 in for y. Now, if you're wondering how to solve it, if I were to put this over 1, I bet you know what to do now. You're going to cross multiply. And if you cross multiply, you're going to get x plus 12 equals 0. That's going to give us x equals negative 12. So negative 12 comma 0 is my x-intercept. Okay. You could also just say, all right, if it's a fraction, for a fraction to equal 0, the top has to be 0. So you just set the top equal to 0. All right, but again, don't forget, you could always put that 0 over 1 and cross multiply that way. And over on this side, we're going to put a 0 in where we see an x and just simplify. Okay, so that's going to give me 12 over negative 4, which is negative 3. So my y-intercept would be 0, negative 3. Thank you, and have a nice day.